In a low-voltage distribution system, an earth fault is not just a technical issue. It is a safety problem that can energize exposed metal parts and lead to electric shock. To correctly design protection against electric shock and equipment damage, you must first understand how the system is earthed. IEC 6034 defines three basic low-voltage distribution systems: TT, TN, and IT systems. In this video, we will understand what each one means and how they differ. Let's begin. IEC standards classify distribution systems using a two-letter code. Each letter has a specific meaning. The first letter tells us how the power system itself is connected to Earth. There are two main possibilities: T and I. T means one point of the power system, usually the neutral, is directly connected to Earth. I means all live parts are isolated from Earth or connected to Earth through a high impedance. So the first letter is about the source side. The second letter tells us how the exposed metal parts of equipment are connected to Earth. Again, there are two main possibilities: T and N. T means exposed conductive parts are directly connected to Earth using a local Earth electrode. N means exposed conductive parts are connected to the Earth point of the power system, usually the neutral. Sometimes you will see an additional letter with TN. We will talk about it later. For now, let's look at each electrical system type in more detail. We will start with the system most commonly found in homes and small installations, TT system. In a TT system, the neutral and the exposed conductive parts are connected to separate, electrically independent, earth electrodes. During an earth fault, the fault current returns to the source through the soil. Because soil resistance is relatively high, the earth fault current is usually low. This is why residual current devices, or RCDs, play a key role in TT systems. According to IEC standard, protection against electric shock in TT systems may be achieved using residual current devices or automatic overcurrent devices, complying with the required disconnection times. TT systems are commonly used in residential installations, rural areas, temporary installations, and small commercial buildings. Now let's contrast this with a system where the earth fault current is intentionally made much higher. TN system, the most common in industry. In TN systems, the neutral is directly earthed. And exposed conductive parts are connected to the same earthing arrangement of the neutral. Here, earth fault current returns to the source through a metallic path. This results in high fault current, which allows fast operation of protective devices. In TN systems, IEC standard permits the use of automatic overcurrent protective devices as well as residual current devices for protection against electric shock. TN systems are further divided into three variants, based on whether the neutral and protective conductors are separate or combined. The first variant is TNS. In TNS, the neutral conductor N and the protective conductor PE are completely separate. This is the preferred system for modern industrial and large installations. The second variant is TNC. In TNC, the neutral and protective functions are combined into a single PEN conductor. This system has limitations and is generally not allowed inside buildings. And lastly, the third variant is TNCS. In TNCS, the system starts with a PEN conductor and later separates into PE and N. Now let's look at a system designed with a very different philosophy. IT system, designed for continuity of service. In IT systems, no active conductor is directly earthed, but it may be connected to Earth through a high-value impedance. Exposed conductive parts are connected to an earth electrode. During the first earth fault, the fault current is extremely low, because it flows through system capacitance and high-impedance paths. According to IEC 60364, Part 4, automatic disconnection of the circuit in case of a single earth fault is not necessary, provided certain conditions are fulfilled. However, the occurrence of a second fault must result in immediate disconnection. To detect the first fault, an insulation monitoring device must be used. This allows corrective action to be taken before a second fault occurs, while the system continues operating safely. Because of this behavior, IT systems are used in hospitals, mines, and other critical installations, where continuity of service is essential. However, it is important to understand that once an earth fault occurs, the system no longer behaves as a true IT system. It behaves as TT or TN, depending on how exposed conductive parts are earthed. As you can see, each distribution system behaves very differently during an earth fault. Understanding these differences is the foundation for correctly designing protection. In the upcoming videos, we will build on this foundation to explain protection against electric shock in TT, TN, and IT systems. Thanks for watching.